Denise said told me she wanted to know who I wanted to be when I grow up, and I have to say I didn't think a physicist was possible. I always loved math and science, and I didn't think I would. But when I started as a freshman at Caltech, I didn't think my background, my public school education in science was enough to get me through the physics major program there, which is very rigorous. But a bunch of friends convinced me to try it out, and I did.
Really thrilled when Macquarie University in 2014 put a little press release out saying that my work was, I think I've underlined it here, my work, which I did with Professor Tansley, who was my PhD supervisor, who sadly passed away, but they pointed to the fact that my nitride work was made a little bit of a contribution to that overall ability to create light-emitting diodes in the white spectrum. And so knowing that your work makes that contribution is very addictive, and something which I guess has always made me want to keep on being engaged in research.
I'm a quantum physicist, and also I think I'm a quantum programmer. And I'm a theorist, so I'm not making any real quantum computer, but I'm all work in the theory, and then I'm working at the University of Tokyo, Japan. So my research area is quantum algorithm, quantum programming, and also understanding the foundation of quantum mechanics. So here is my group photo, and then this I usually use pen and paper, and then this my office desk is lots of computers. So, and then I'm a wife of a British businessman, and I'm a mother of a 19-year-old son, and I'm also currently working as a council member of Association of Asia Pacific Physical Societies.
This quantum volume benchmark was actually a scheme that was proposed by IBM because back a few years back they realized that number of qubits wasn't adequate to tell the story of how good your quantum computer is doing, and so most of the time our quantum computers are really limited by the errors on the system, and so in this quantum volume benchmark, the system has to be able to perform quantum programs with depth that are equal to the number of effective qubits, with some reasonable probability of getting to the right answer. And so it's a very stringent test, and we ran the quantum volume algorithm from the Qiskit from IBM. And we show here in this plot that with 6 qubits, we were able to execute programs with depth 6 and be able to pass the test with very little trouble there. And in fact, our error rates are good enough that we can probably increase a few more qubits in the future at that same error rate and be able to expand our quantum volume.
And as a member of the European Parliament, we always look actually what's in it for the people. How do we improve the welfare of our people? How does this new kind of technology is going to help us in order to improve our health systems, our educational systems, our social systems? All these questions which are connected with how do we actually help that people have a better life, that is also what is affecting us as politicians in the European Parliament. If I look at what the European Union has done so far in order to boost quantum technology, I have to tell you that there have been 2 things which had been brought on the spot. First of all, in 2018, there was this joint quantum initiative, which had been initiated by the European Commission. It was a pledge of 1 billion euro, actually, which was made available so that quantum technology can be supported all over the member states in the European Union. And just recently, we began updating the European High Performance Computing Joint Undertaking. It pledges 8 billion euro to provide access to this technology for both public and private users, and in particular also for small and medium-sized companies. So that's what Europe has done so far. Again, for me as politician, the most important question is, and I think this will also be addressed during the conference, which is going to take place right now and tomorrow, is the question, what impact quantum technology is going to have for people? How does it help in order to improve our systems? And in a nutshell, how can we arrange for using this technology for a better life and a better world? That is what we as politicians want to discuss.
I mean, this is one place, probably the highest concentration of, women with PhD in optics, physics, and also technical fields like engineering and IT and everything. Yeah, I think it's very rare to be working in a place with so many women around, in a very technical field. And so I was very glad to see. My name is Patty Lee. I'm the Chief Scientist at Honeywell Quantum Solutions.